Hello. In today's session, we will clear your doubts about this uh, question from Cambridge, Cambridge paper, which is basically surrounding the transition elements. Okay. So this is actually taken from the chemistry paper, and we are going to jump straight into the question. So let's start here. They say that zinc and copper are elements next to each other in the periodic table. So one thing that you need to realize is that zinc and copper, they are lying right next to each other in the periodic table. Okay. So zinc and copper are essentially called transition elements. Okay. So they're also called transition elements. What are transition elements? Transition elements are elements that are found right in the center of the periodic table, and we usually call it a D block. Okay, so like letter A, B, C, D, it's called the D block, and it contains elements that have partially filled subshell in any oxidation state. So what do I mean by that is they keep changing their oxidation state. For example, copper can carry the oxidation state of 1 or 2, right? And zinc can also carry an varying oxidation state, as opposed to other members of the periodic table, which carry fixed oxidation states, right? Another example of transition element is iron, that also carries three different kinds of oxidation states, from +1 to +2 to +3. Okay, that was a brief description about periodic table. Let's move on to this question now. The A part suggests that zinc is obtained from zinc blend in a two-step process. Okay, so when you read the first line, you become familiar with the question that they're asking you about the extraction of zinc from zinc blend. Okay, and then they give you an overview in the question itself. They say in step one, zinc blend is converted into zinc oxide. Okay, so zinc blend is converted into zinc oxide in step one. And in step two, the zinc oxide, which is made in step one, is then converted into zinc in a blast furnace. Okay, so the reason why they added the word here, blast furnace, is to let you know that it is done under high temperatures. Okay, so they're just giving you a hint here. Then they say that outline how each of these steps are done. In your answer, give one chemical reaction for each step, and also describe how zinc is removed from the blast furnace in step two. So they've asked you a number of things here. We will take a look at it step by step. Okay. So step one, let's move back to the question here. They say that in step one, zinc blend is converted into zinc oxide. Okay, so in step one, you have to give a brief outline first that how zinc blend is converted into zinc oxide. So zinc blend is converted into zinc oxide by roasting it in the air. Okay, so the particular word that you have to use here is roasting. It is not a slang word. It is actually a word that needs to be used in the marking scheme criteria, because it is actually exposed to a high level, high temperature of air, essentially steam. Okay, but we usually would write air here as opposed to steam and use the word roasted instead. Okay, so that's why I have said that zinc blend is converted into zinc oxide by roasting it in the air. And this is backed up by the chemical equation that I'm going to write here. Zinc oxide is zinc sulfide. So zinc blend is basically a sulfide ore. Okay, it is a mixture of zinc and sulfur. That's why it's called a blend, right? So zinc sulfide reacts with oxygen or air, also steam, okay? All of this will show off as oxygen. Once it reacts, it gives rise to zinc oxide, and resulting byproduct is sulfur dioxide, okay? The sulfur dioxide evaporates, vaporizes eventually in the air, and zinc oxide is the solid product of this equation that we need, all right? Now, it's very important that you balance your equation. Unbalanced equation will get you no marks. So make sure that the equation is balanced. As you can see, 2 zinc sulfides react with 3 oxygen to form 2 zinc oxide and 2 sulfur dioxide. If you will not balance the equation, the question, you will lose marks for the chemical equation and it will be rendered useless, okay? Anyway, moving on to step 2 here. Let's go on and go back and review what step 2 says. In step 2, zinc oxide is converted into zinc in blast furnace. So now you have to outline the process where the zinc oxide that we obtained from step 1 is converted into zinc. So in step 2, how it is converted? Zinc oxide is then mixed with coke. Okay, coke is basically analogous to coal. So you can say the zinc oxide is then mixed with coke, and converted into zinc. All right. Chemical equation to back it up is again zinc oxide here, and zinc oxide reacts with carbon and gives off zinc as a solid material that we want in the end with carbon monoxide. Okay. So the gas in step 2 is carbon monoxide, and the gas in step 1 is sulfur dioxide, okay? And then they ask you that how is zinc removed finally in step 1 in its pure form, right? So zinc over here is actually collected as vapors. And once it vaporizes, it condenses back and then it goes through something called fractional distillation. So this is the process that ultimately collects zinc in the final step. Okay, so removal of zinc is by fractional distillation. Then in the next part, in B part, they ask you, name the alloy formed when zinc is mixed with copper. So first off, let's discuss what's an alloy. An alloy is basically a mixture of more than one element, okay? And it's basically made from the transition elements. So an alloy will be a mixture of 2 elements, and they are asking the name of the alloy that has zinc and copper in it. So the name of that alloy is brass. Okay, it's called brass, and if you need to be specific, it has 70% copper and 30% zinc. All right, but we won't go into the details. But if there's another question, you can always answer that. It has 70% copper and 30% zinc. Okay? So in C part, they ask this to tell you that copper is a transition element. So we have previously discussed what's a transition element, an element that has incomplete subshells, right, and various oxidation states. And they have stated it themselves, just in case you don't know, it can have variable oxidation states, all right? So the question that follows here is state. So since they're asking you to state, you are not going to write lengthy lines, just going to state. State 2 other chemical properties. So one chemical properties they have already described its variable oxidation state, but you need to name 2 other chemical properties of the transition elements which make them different from group 1 elements. Okay, so one of the most famous purpose of transition element is that they act as catalysts in chemical reaction. So catalysts are basically elements that fast up or speed up the rate of chemical reaction, and transition elements is the only group in periodic table that are used as catalysts. All right. Another telltale sign of a transition element is that they form colorful compounds. Okay, for example, iron is also green, it's also brown in different oxidation states, right? And copper is gold and black in different oxidation states. So they form colorful compounds, right? So this was all for this question. I hope it was clear, the whole process of extraction of zinc from zinc blende, and all your doubts have been cleared as well. Thank you and take care.